Steps. Today we are moving on to G3 Part B, or is it G2? G3 Part B, and we're going to find area of sectors. And steps for finding the area. You find the actual area, which is this pi r squared. The actual area is pi r squared. And then you're going to find the part of the area it takes up. Remember, a sector takes up a part of a whole circle, a fraction of the circle. Of means multiply. That's why we do fraction times the whole area, because a sector takes up a fraction of the whole area. Okay? So we're going to find the area of a sector that covers an eighth of a circle that has a diameter of 10. So this to me looks like the drawing. I cover an eighth of the whole circle. And if my diameter is 10, I need to know my radius for area. Area is equal to pi r squared. So my radius is what? 5, yeah? So then my whole area is 5 squared pi, which is 25 pi. That's my whole area. That's the whole entire circle. But I just need a fraction of it. Of means multiply. What fraction is it? An eighth. So I'm going to go 1/8 times 25 pi. I can't cross simplify, so it's just 25 pi over 8. And that's my area. You don't add anything because adding is perimeter. Perimeter is adding around. Area is just filling it up. Okay? This is way better than yesterday's. But we're not done with the lesson yet. You might change your mind on the next page. Okay, find the area of a sector that has a radius of 8 and covers 3/4 of the circle. Again, I'm going to find you go fraction times pi r squared is really what you're doing. You're doing the part the sector takes up times the whole area. R is 8, so it's going to be a fraction is 3/4. 3/4 times 8 squared is 64. 64 pi. Now I can cross simplify. Now my brain, some of you know this, but my brain doesn't know if 4 goes into 64, but I do know they're both even. So I can half them both. They're both even again. And some of you already knew it was 16. I don't. I don't know that fact off the top of my head. Now I can go 16 times 3 is 48 pi. I am done because area is just filling up. It's not adding around. Okay, so we can, on the previous page, you found area of a sector, knowing the fraction the sector takes up. Sometimes you don't know, and you know what's called a central angle. That's an angle that the sector makes. What you're going to want to do is create a proportion. In the main proportion that we utilize, the main proportion goes back to chapter 6, where we utilize part is to whole as part is to whole. We use that to create proportions with our angles and circumference. So there's two main proportions. When you think about part of a circumference, you're going to have something like x. There's a part. It's called an arc length as part of a circle. Arc length is to the whole circumference, 2 pi r. That's the whole thing. part is to whole as, now there's going to be something else. We need another part and whole. Well, here we're given degrees. As 87, part of the whole degrees is to the whole degrees. How many degrees in a circle?
360.
360. Part is to whole as part is to whole. And we go from there. So this is going to be your, it's called an arc length. It's the part of your circumference. It's not the whole perimeter. It's just this part. Just that part. So you'd still have to add the radius. Just that part and just that part. Again, part, the arc length, is to the whole circumference, 2 pi r, as part of the degrees is to the whole degrees, 360. And now with area, same thing. Part is to whole as part is to whole. So for area, you have an area part, that would be this part, is to the whole area, pi r squared. As part, I need another part in whole. Well, I'm given my degree measure, and my degrees is a whole 360. So this is our area proportion. So you have an arc length and an area proportion. Okay, we're going to apply this. So the first circle has a degree measure of 87, and I don't know what fraction of the circle that is. So I'm going to have to create a proportion. So I'm going to find perimeter and area, one thing at a time. I'm going to get the worst over with first. Perimeter. To find perimeter, I need to find this, that arc length. To find that arc length, I create that proportion. That's right here, this proportion. So I say the arc length is to the whole circumference as 87 is to the whole degree measure. I know r is 3. So that's actually 6 pi on the bottom. And now you can go about solving this proportion multiple ways. I'm just going to keep pi on my calculator till the end. Okay, so I'm just going 87 times 6, and then I hit the pi button, divided by 360, and that is equal to 4.6 estimated. Now this 4.6 is just what I outlined in red above. That's just the arc length. That is not my whole perimeter. So my whole perimeter is going to be radius plus that arc length. 6 plus 4.6, 10.6 is my perimeter. Whew, that's my perimeter. Love it. Okay? Not too bad, but horrible. This is as bad as it gets. I wouldn't say horrible. I love geometry. It's kind of fun. Now, area is always the nicer one. Again, I don't know the fraction, so I create that proportion. So my area of the sector, create the proportion. So my part of the area is x. I don't know what that is to my whole area, pi r squared. Right? The whole area of a circle is pi r squared. As my part of the degrees is to my whole degrees. Now I know r is 3, so 3 squared is 9. So this turns into x over 9 pi equals 87 over 360. And now I just start multiplying. 87 times 9, I hit my pi symbol, and then I divide by 360, and that gives me 6.8, and I'm done. I know that I'm done because it's not perimeter. I'm not done if it's perimeter, but if it's area, I'm done. Okay, the next one, when I was making this, I totally forgot about a radius. So why don't you go ahead and write 9 as your radius for this? next one, you need a radius. I forgot all about the poor little radius.
Yep. Oh yeah, did you figure that problem about the pool and our
No, I forgot to even look at it. So moving along with this, notice 270 is really 3/4 of a circle. So you could always go 3/4 times pi r squared, or how we found perimeter previously. I'm going to show you that you can do it either way. The only time I make a proportion is if I don't know the fraction of the circle it takes up. So perimeter. Part, I'm just going to call it P. Part of my perimeter, that's that arc length, part of that is to the whole thing, that's the circumference, 2 pi r. As, now I need another part and another whole. As part of my degrees, the 270 is to my whole degrees. R was 9. So I get x over 18 pi equals 270 over 360. Now how do I know it's 270? Because you follow the circle it gives you. Notice here, I think in your notes I erased it, the circle goes like that. So it's saying the sector is really this big part. Here the sector was this little part. The first one, the sector was the smaller part. Okay? Alright, so I punch it into my calculator. 270 times 18 pi divided by 360 is 42.4. That is not the whole thing. All that told me was this. Oh yeah, that's all that told me. Now I need, that's part of my perimeter, but I also need to add together the radiuses. So my perimeter is really 9 plus 9 plus 42.4. So that's 18 plus 42.4, which is 60.4. Good, I got the worst over with. That's the worst. Now we'll do area. And the nice thing about area is you're done in one shot. So area. Part of my area is to the whole area, pi r squared, as part of my degrees is to the whole degrees. What's going on? R is 9, 9 squared is 81. X is to 81 pi as 270 is to 360. 270 times 81 pi divided by 360 is 190.9 rounded. And that's going to be a squared unit. I don't know what it is, but area is always square. Just so you know that the fraction times it is the same. If I were to go with, just so you could see, 3/4 times 81 pi is still going 81 times 3, 81 pi times 3, and then I divide it by 4 is the same thing. Okay? It will give you equivalent answers. So the only time I create proportions is when I don't know specifically what fraction of the sector it takes up.